In this video, I want to talk about the vertical angle theorem and when we use it as a reason in a proof. Let's go back to a sample proof. So here's a proof that we've started and gotten a little traction in. Remember, a vertical angle happens whenever you've got two intersecting lines. If you've got two intersecting straight lines, they form four angles when that happens. And the ones that are on opposite sides of that intersection point are what we call vertical angles. And the vertical angle theorem just says that whenever we've got this situation, these vertical angles have to be congruent, just part of it being straight lines. You can imagine that if we just did a rotation around that intersection point, those congruent angles, those vertical angles just line up with each other. So they must be congruent to each other. So that's the vertical angle theorem. You're going to use this whenever you recognize this shape in a proof. If you've got two intersecting lines and the angles on the opposite sides of that intersection point are important in your proof. All right, so coming back to this proof that we've done before, do you recognize which angles we can use the vertical angle theorem on? And if so, can you name the two of them? Well, we've got the intersecting lines right here in the middle of the diagram. We've got vertical angles here and here on the left and right hand side, but they're probably not going to be very important to us because they're outside of the diagram. The top and bottom angles, though, these are part of these two triangles. So that looks like it's going to be an important thing that we're going to want to show. And just like given statements, you can, whenever you identify vertical angles, you can just drop them into the proof wherever you want. You don't need any evidence earlier in the proof to justify that. So the two angles that are congruent, there are a couple different ways to name them, but the top angle, we're going to go from A to E to D. That's how we spell out that angle. You can also go D to E to A. Either of those would be acceptable ways to name that angle. But notice the E has to be in the middle. It's the center point, the vertex of that angle. And the angle down at the bottom, we do the same thing. So we're going from B to E to C, or we can go from C to E to B. Either of those are okay names. Notice that here in line 2 of the proof, we said that angle C was congruent to angle D. We could name those angles in one letter because there wasn't any confusion about what angle C was. But there would be a lot of confusion if I said angle E. You wouldn't know if I was talking about this top angle or the bottom angle or maybe even the two side angles. So these are times when you need to use the 3-letter names. And my reason for this is because we recognize the relationship between these two angles are their vertical angles, because they're made up of the two straight lines that both intersect at that common vertex of E. All right, so that's when you're going to use vertical angles. When you look at a diagram and you see that there are two lines intersecting each other, you want to kind of keep your eye open for whether vertical angles are going to be an important part of supplying evidence that you've got those two congruent angles in the diagram. Sometimes they're not a part of the two triangles that you need to prove are congruent, but if they are, that's a really easy way to find a pair of angles that bring evidence to triangle congruence.